Welcome. This question says a solid cylinder of 4 kilograms has a moment of inertia about its center of mass of 6 kilogram meters squared. What is the moment of inertia of the solid cylinder about another axis that is located 2 meters from the center of mass? So let's visualize this. We have a solid cylinder. And I can say, you know, there's my center of mass is on that axis there, so I'm imagining a rotation about there. And when I have my moment of inertia about that point there, moment of inertia about my center of mass is equal to 6 kilogram meters squared. And then I'm saying, well, supposing that you're not going to rotate about that center of mass. Suppose we're going to rotate about a center of mass that is 2 meters away. So this here, that distance there is 2 meters. 2 meters away. So let's call this P for parallel. Then I about the parallel axis is equal to I don't know. And this actually is attacked using the so-called parallel axis theorem, which is that the moment of inertia about some axis, your parallel axis, is equal to the moment of inertia about your center of mass plus m times d squared, where m is the mass of the entire object and d is the distance between the two parallel axes. Now, sometimes people will say, well, yeah, get another equation to remember. But if you think about it, moments of inertia have units of kilogram meter squared. And we learned in chapter 1 in dimensional analysis that you have to have the same dimensions on either side of an equal sign. And you also have to have the same dimensions for pluses and minuses. So if this is in kilogram meter squared, then this has to be in kilogram meter squared. And so it makes sense to multiply a mass which is in kilograms by a distance which is in meters squared. A distance squared which is in meters, which makes meters squared. Yeah, there could be a half, there could be a quarter, there could be some, you know, constant in front of this, but there isn't. There's just a number 1 in front of this, and so that's what I remember. I know, well, this is going to be the same as that, modified by this value here, and oh yeah, it's not got a weird number in front of it, it's just got the number 1. So then what I do is I simply say, well, okay, my moment of inertia about my parallel axis, my new axis, is equal to my moment of inertia about my old center of mass, which was 6, plus, and then I have my mass of my entire object, which was 4, and then I have the distance between these two parallel axes, which is 2, and I got to square it. So I have my parallel axis is equal to 6 plus 4 4 is 16, which equals 22. So the moment of inertia of my object about this new axis is equal to 22 kilogram meters squared. Quite a difference when you think about it. By moving the axis of rotation away from the center of mass axis, I've increased my moment of inertia, which is my, you know, reluctance to accelerate angularly, quite significantly. This does not only work for solid cylinders. I could have any shape of object, and if I know the moment of inertia of an axis about the object about an axis which passes through its center of mass, and I want to know the moment of inertia of the same object about an axis which is parallel to the first one, then I can simply work it out using this expression. So it's not limited to solid cylinders, but it is limited to parallel axes. The original axis that you have the center of mass about, that you have the moment of inertia about, must go through the center of mass, and the new axis must be parallel to the old axis. So there we have it.